Today is 25th February 2026. It is IGCSE Physics, magnetic force on a moving charge particle, and you are given this region. In this region, the magnetic field is directed into the page. The magnetic field is directed into the page. And in this magnetic field, alpha particle, remember alpha is a positive particle, alpha particle is projected. When alpha particle is projected in this direction, the charge particle experiences a magnetic force, and this magnetic force direction is determined by Fleming left-hand rule. And Navia, you have to apply this rule. So the Navia, keep your first finger, left hand first finger, towards the screen because magnetic field is directed into the page. And now then open your second finger in the direction of moving charge particle. Charge particle is moving towards the right hand side. So we can say this is the direction of current. So we can say this is the direction of charge particle. Where is your thumb? Where is your thumb? Upward. You are right. It means magnetic force acting in upward direction. But remember, when a force acting perpendicular to the direction of motion, then the path of the moving charge particle becomes circular. It means charge particle will be deflected like this. Magnetic force acting in upward direction, magnetic force acting in upward direction. So the charge particle will be deflected in upward direction. And now the question is in the shaded region, draw the possible path of alpha particle. So, sir, you have drawn this green path. It is the path of possible path of alpha particle. And now the second part. The second part question is state and explain effect on this path of reversing the current in the coil. Actually, this magnetic field is produced by current in a coil. So if you are reversing the direction of current, it will reverse the direction of magnetic field. In this question, magnetic field is into the page. If you reverse the direction, then obviously magnetic field will be out of the page. Magnetic field will be out of the page. So I am writing one by one. When you reverse the direction of current, magnetic field will be out of the page. When direction of current reverse, it will reverse the direction of magnetic field. And when the direction of magnetic field will reverse, the magnetic force direction will also be affected. But in this question, they are asking what will be the path? What will be the path? So I should write only about the path. Alpha particle, alpha particles will move downward along curve path. So whenever the direction of current is changed, the direction of current, it will reverse the direction of magnetic field. In this question, the direction of magnetic field, it was into the page, but now it will be out of the page. And when the direction of magnetic field is reversed, it will reverse the direction of magnetic force. So the direction of magnetic force will be downward. So the charged particle will be deflected in downward direction. This is question from November 2013. It is very old question. And now this is latest question, June 2022. June 2022. In this question again, you are given a magnetic field, and you know magnetic field is directed from north to south pole. North to south pole. So open your first finger, left hand first finger from north to south, and then open your second finger in the direction of charge particle. Charge particle is moving in this direction. But Atif, can you help me? Where is the direction of your thumb? And you are using Fleming left hand rule. Atif, first finger from north to south, first finger from north to south, second finger, you are saying your thumb is pointing downward? Wrong answer, because my thumb is pointing upward. Give it up, Pavitra, and ignore with what is the particle. We are dealing only left hand rule. हाँ बेटा पवित्रा, can you apply Fleming left hand rule and check कि Atif is correct or I am correct? My first finger from north to south. This is north, this is south. This is my first finger. Then my second finger pointing this direction because charge particle moving in this direction. But Pavitra, where is your thumb? Upward or downward? It is upward. Okay. And if for thumb is upward, then obviously magnetic force will be upward. But remember, this is the rule which we have studied for left hand rule. It apply only positive particle. This is rule only for positive particle. But you know, beta is negative particle. And if beta is negative particle, when the nature of charge is reversed, then the direction of magnetic force will be reversed. So the magnetic force on the beta particle will be downward. Magnetic force on the beta particle will be downward. So force on negative beta particle, beta is negative particle. First, we find the direction of positive particle. So positive particle direction will be upward. Positive particle direction will be upward. Force on positive particle upward. But force on negative particle it will be downward. So the right answer I have explained. And now another question from June 2015. The question is the magnetic field is directed into the page. Okay, my first finger is towards the screen, but the charge particle is moving in this direction. It is very difficult to settle your left hand fingers. But Anavia, you have to help me. Gee, my first finger pointing toward the screen. My second finger is in the direction of green. Then where is your thumb? And I am giving you two options. Thumb is pointing upward. Thumb is pointing in this direction. Thumb is pointing in this direction. Thumb is pointing in this direction. A, B, C, D options I am giving you. G button Navia, where is your thumb? Where is your thumb? I'm giving you option A, B, C, D. This is B, this is C, this is A. Yes, you are right. You are right. You are right. Now, Navia is a specialist, I think, in left-hand rule. So the magnetic force, thumb pointing this way, but this thumb shows the direction of on positive particle. So, but the particle is negative. So negative particle, so the direction will be reversed. So force on beta particle will be blue direction. Force on negative beta particle, it will be blue direction. Okay, because a thumb pointing for positive particle. And now the last question on this topic, November 2020. The question is, sir, again there is a North Pole and South Pole. But Atif, you have to solve this question, Atif. This is north to south, so your first finger should be like this from north to south. And the second finger is very easy to keep, it is downward. and ignore is it negative or positive. First, you should ignore it. G. Ate bhai, where is your thumb? This is first finger, north to south. This is second finger, direction of motion, charge particle moving downward. Where is your thumb? Ate? Outward. You are right. You are right. So my thumb is pointing out of the screen. But this is outward for positive particles, and this is negative particle. And if it is negative particle, then obviously direction of magnetic force will be opposite. And opposite means it will be behind the screen. Okay. So read the question. Describe what is meant by direction of magnetic field. Okay, I'm going to explain as well. Describe and explain what happens to the beam of electron in the magnetic field between the poles of the magnet. Okay, actually, in this question, they are not asking the direction of magnetic force. They are not asking the direction of magnetic force. They are asking what happens to the beam of electron. So I am explaining. So I am explaining. Uh, a magnetic force will act on the beam of electron. A beam of electron, sorry, a magnetic force will act on the beam of electrons. Its direction can be determined by Fleming left hand rule, and it is inward into the page. But they are not asking. They are not asking. The magnetic force will be acting inward into the page. So electron deflect. So beam of electron will deflect. Beam of electron will deflect. 530 बोला था. Beam of electron will deflect, and it will be deflected into the page, into the screen. Okay, so this topic I think we have completed, and no more question in my read and write book. And we have done at least four questions, so it is enough. And now we should move forward. And now we are starting our next topic, that is DC motor. DC motor. So what is DC motor? You know, DC motor is a device which converts electrical energy into mechanical energy. Mechanical energy means, you know, when current passes through a coil, then the coil begins to rotate. Kinetic energy, rotate. And when an object rotates, then this rotation can be used in our daily life. My fan is running by motor, etc. So electrical energy is the input and movement, mechanical energy is the output. It is the introduction. And now we are going to study the construction and working of DC motor. So everyone knows, sir, there are four essential parts of a DC motor. There are four essential parts of a DC motor. Four essential parts. This is the first one. This is permanent magnet. This is permanent magnet. And you know, permanent magnet produces magnetic field between its poles. Consider this is the North Pole. Consider this is the South Pole. Then obviously there is a magnetic field between the poles. And now this is a coil of wire. This is a coil of wire And this coil of wire is supported on a rod, and this rod is known as axle. Axle is a supporting rod. Axle is a supporting rod. And on this rod, the coil is supported. Then you know there are two ends of the coil. There are two ends of the coil. This is the first end of the coil and it is connected with the commutator. So what is commutator? I'm going to explain. One end of the coil is connected with one piece of commutator and the other end of the coil is connected with other piece of other piece of commutator. So these are two commutators, and these commutator, remember, commutator will move with coil. Commutator will move with coil. Commutator are not stationary. Commutator will turn with coil, but this is called carbon brush, and this carbon brush will remain at rest. Carbon brush will remain at rest. Carbon brush will not turn. Carbon brush will remain at rest. And now these carbon brushes are attached with a DC source because we are studying DC motor. So this is attached with the positive and negative terminal of DC source. This is the DC source and it is connected with the carbon brush, and this is carbon brush. This is carbon brush, and remember carbon brush will remain stationary, will remain fixed. So this is carbon brush and this is commutator. Some teachers call it commutator, some teacher call it split ring commutator. It is split ring commutator. Okay, so there are four essential parts of a DC motor. Number one, permanent magnet. Number two, coil. Number three, carbon brush. Number four, split ring commutator. And you do not need to draw because in your exam they do not ask you to draw. They do not ask you to draw. You will be given a diagram and you have to labeling their names. So we have discussed. And now we are going to study its working. So let's start to study its working. Sir, when current passes through the coil, when current passes through the coil, then you can see, so there are two sides of the coil. These are two sides of the coil, and consider I am calling this side as PQ and this side I am calling RS. This is PQ side, this is RS side. Okay, and now as current passes through the coil, then obviously each side, this side and this side, will experience magnetic force. We have studied in the last class, so when current passes through us wire, then it experiences a magnetic force. Then obviously, so this side PQ and this side RS will experience magnetic force. But you can see, so the direction of current in the two sides is opposite. The direction of current in the two sides is opposite. This is in this direction. This is in this direction. So their directions are reversed. Their directions are opposite, not a reverse. Their directions are opposite to each other. And you know, if the two sides carrying current in opposite direction, then they will experience magnetic force in opposite direction. So if I say, sir, this side will experience an upward magnetic force, then this side will experience a downward magnetic force. Sir, why? Because the direction of current is opposite. When the direction of current is opposite, when the direction of current is opposite, then obviously the direction of magnetic force will also be opposite. And I think this side will be upward and this side will be downward. And not necessary to use, no, not necessary to explain in this question Fleming left hand rule. Actually, now I am explaining. So the two sides, I you should write, but I think you should write. So side PQ, sides PQ and RS carrying current in opposite direction, carrying current in opposite direction. So they experience they experience magnetic force in opposite direction. Sir, current is in opposite direction, so magnetic force will also be in opposite direction. And two forces acting on the coil in opposite direction. So due to this couple of magnetic force, the coil starts rotating. Due to this couple means two forces of equal magnitude acting in opposite direction. Due to this couple of magnetic force, due to this couple of magnetic force, coil starts rotation. Coil starts rotation. Note down this working. But it is very easy to say, sir, when current passes through the coil, coil starts rotation. But there is an issue, and this issue is resolved by commutator. That is why in exam you will check, they will ask what is the function of commutator. They will ask what is the function of commutator. So I am going to explain the issue and then it is resolved by commutator. Sir, what is the issue? Sir, issue is if there is no commutator, then the coil cannot complete its one rotation. Even one rotation, coil cannot complete. But in the presence of commutator, coil easily continue its rotation. So, sir, what is the function of commutator? I'm going to explain. The explanation is consider consider this side PQ, this side PQ connected with this commutator, and I am giving name this commutator as PQ. This is commutator PQ. Okay. The right hand side, side is RS. The side is RS, and the name of the commutator, sir, it is RS. So commutator name is PQRS. Okay. And now I am explaining. The explanation is, sir, right now, the coil is horizontal. Okay. The coil is horizontal. But when coil turns through 90 degree, when coil turns through 90 degree, through 90 degree, then what happens? I am explaining with the diagram. This is carbon brush, this is carbon brush, and as I told you earlier, sir, carbon brush remains at rest. It is fixed. But when the coil turns, then the commutator moves like this, and the position of commutator will change like this. This is the new position of commutator when the coil turns 90 degree. And if we are assuming the coil is turning in anti-clockwise, the coil is turning anti-clockwise by these forces, then this side RS, this side RS will move to upward, and this side PQ will move to downward. And for this situation, no current passes through the coil. No current passes through the coil. Sir, why? Because the current is coming from the battery, and this current is coming up to the carbon brush. But in this diagram, the carbon brush is not in contact with the commutator. So no current is passing through the coil. But due to the inertia, due to the inertia, the coil with commutator continues its motion, continues its motion. And when it further rotates 90 degree, then this side RS will be on the left hand side when it has turned 180 degree. When it has turned 180 degree, for further 90 degree, for further 90-degree rotation, the carbon brush remain at their fixed position, but the position of commutator are interchanged, are interchanged. And now you can see the side RS is on the left hand side, and side PQ on the right hand side. Side RS on the left hand side, side PQ on the right hand side. So their positions are interchanged. Positions are interchanged. Okay. And now you have to memorize this paragraph. This paragraph is important, which now I am writing. This para you must memorize. After after every half rotation of coil, commutator, actually commutator interchanging their position. When their positions are interchanged, when their positions are interchanged, when this RS, when this RS is here, when this PQ is here, they have interchanged their position, and now RS, sir, initially RS current was this. It was the direction of RS. But when RS on the left hand side, the direction of current will be upward. The direction of current will be upward. So simply you have to memorize, sir, after every half rotation of the coil, commutator reverses, reverses the direction of current, reverses the direction of current in the coil. When coil turns, when coil makes half rotation, commutator interchanges their position. When commutator interchange their position, it will reverse the direction of current in the coil. And when the direction of current in the coil is reversed, it will continue. It will continue the coil to turn in one direction. You have to memorize this paragraph. They ask again and again, what is the function of commutator? What is the function of commutator? What is the function of commutator? So the function of commutator is, sir, commutator reverses the direction of current. Commutator reverses the direction of current. After every half rotation, commutator reverses the direction of current. And by reversing the direction of current, now the coil can continue to turn in one direction. If you remove commutator, then the coil cannot complete rotation. Coil cannot complete rotation. Why? Sir, actually the function of commutator is, sir, commutator reverses the direction of current, and by reversing the direction of current, by reversing the direction of current, the coil keep on rotating in one direction. Sir, do we have any formula for DC motor? No, no, you do not have any formula, but I will say the coil is turning, the coil is turning, and if an object is turning, then obviously there is turning effect. And the equation of turning effect for DC motor is MINA, MINA. The turning effect of DC motor equation is MINA. So what is the meaning of MINA? Actually, this M stands for strength of magnet. Strength of magnet. If the magnet is strong, it will produce a strong turning effect. If the magnet is weak, it will produce weak turning effect. So if you are interested to run your motor at a high speed, then obviously you should use a strong magnet. Number one. Number two, if you want to control the speed of motor, sometime I need to turn fan at a high speed, sometime I need to turn fan at low speed. So its speed can be controlled by current. If you increase current, then motor will run fast. If you decrease current, the motor will turn slow. So current is the tool by which we can control the speed of the motor. Sir, what is N? N means number of turns of coil. So what does it mean? Actually, in the last diagram, in this diagram, I drew this rectangle. And actually, this rectangle is a frame. This rectangle is a frame. The coil is wound on the frame. One, two, three, four, five, six. Thousands time. The coil is wound on the rectangular frame. So if you increase number of turns on the coil, then the turning effect will be larger. If you are widening less number of turns, then turning effect will be lesser. So the turning effect depends upon number of turns. And the last thing, the turning effect depends upon area of the coil. You can see in big motors, the coil area is very large. In small motors, very small coil is used. So by changing these four variables, you can control the turning effect of motor. And now we have completed this topic at very high speed because it is a crash course and we are moving fast so that we can revise all these topics, the whole course within 3 to 4 months. Now we are solving this question. This is DC motor. The question is DC motor question is, sir, we are given this is a split ring, name is given. This is carbon brush, this is coil. Okay, sir, we are given names. So what is the question? The question is state and explain the direction of rotation of coil. Okay, we have to apply Fleming left hand rule and then we have to decide in which direction the coil will turn. So let's start. So this is positive terminal. So the current is flowing in this direction. This is the direction of current. This is the direction of current. And consider this side is PQ. This side is PQ. And beta Nevia, can you help me again for applying left hand rule? And I'm asking you to keep your first finger from north to south. Nevia, first finger from north to south. And then your second finger in this direction. Then where is your thumb? Upward. You are right. You are right. So the magnetic force on this side, the magnetic force on this side, sir, acting upward, and the magnetic force on this side acting downward. So I am erasing all other arrows, and now only two arrows I have mentioned. This arrow, this is the current direction, this is the current direction, but the magnetic force acting like this. And if the magnetic force is acting like this, then beta Pavitra, can you tell me coil will rotate in clockwise or in anti-clockwise direction? Pavitra? Yes, you are right, sir. It is clockwise because it is acting upward, it is acting downward, so it is turning clockwise. So statement is, sir, clockwise rotation, clockwise rotation. And now they are asking explanation. So explanation is using Fleming left hand rule, magnetic force on left side is upward, right side downward. So turning effect produce. So turning effect is produced. And now, right now, the coil is horizontal. And the question is, sir, when the coil rotates 90 degree, 90 degree from the given position, what happens? Sir, when it turned 90 degree, no current will pass through the coil. No current pass through coil. Okay. No current pass through coil. So coil should stop. But due to the inertia, it continues its rotation. And when the coil is rotated through 180 degree, it means half rotation. Half rotation. How the split ring commutator, how the split ring commutator, how the split ring commutator. enable motor to turn continuously? So the answer is, so the split ring commutator reverses, split ring commutator reverses the direction of current. So forces forces on each side reversed, thus coil turned continuously. Thus coil turned continuously. So in this question, they ask what is the function of split ring commutator? Sir, we have studied earlier. Sir, the split ring commutator function is it reverses the direction of current. It reverses the direction of current. And when the direction of current is reversed, when the direction of current is reversed, it will reverse the direction of magnetic force on the two sides of the coil. So the coil will keep on turning in one direction. And now the next question is, I think you can solve yourself because again the coil is placed between the two poles of the magnet. Draw the pair of arrows to show which way the coil turns. Okay, so it means again they are asking to apply left hand rule. So this is positive terminal and this is negative terminal. So Atif, Atif, can you apply a Fleming left hand rule with me? Now place your first finger from north to south. Atif, okay, this is my first finger. And now I am asking you to place your second finger here. It is easy. The second finger is here. Then where is your thumb? Left upward. So the magnetic force will be acting upward on this side, then obviously downward on this side. Obviously downward on the other side. So I think current direction I should draw. This is the direction of current, and this is the direction of magnetic force. So they ask draw a pair of arrows I have shown and explain the direction you have chosen. Explain the direction. So I used Fleming left hand rule. And I think I should not rewrite the whole sentence again and again because this is a crash course and we have discussed in the last question. And now the next part, draw an arrow to show the direction of electrons flow. Electrons flow through the coil. Okay. Electrons flow. So you know the direction of current opposite to the direction of electrons flow. Sorry, electron flow will be this. Electron flow will be this. So draw an arrow to show the direction of electron through which the coil. So this is the direction of electron, and I am writing electron. Direction of electron flow opposite to the direction of current. And now I explain why the electron flow in the direction we have shown in A2. Explain why electrons flow. Sir, you know electrons flow. Electrons flow opposite to the conventional current. Opposite to the conventional current. Opposite to the conventional current. Okay. Electrons flow is always opposite to the direction of conventional current. And now stated any difference each of the following changes make to the rotation of the coil. Number one, sir, changing the polarity of power. Arre sir, if you reverse the polarity of power, you have reversed the polarity of the power. It was positive left side, but now it is positive on the right hand side. Sir, it will reverse the direction of current. It will reverse the rotation of the coil. Reversing the direction of current, reversing the direction of current will reverse the direction of coil, reverse the rotation of coil. When the polarity of battery, the polarity of power supply is reversed, it is reversing the direction of current. A1 को उठा दिया, and it will reverse the rotation of the coil. Okay, so this question is completed. And now, sir, you are given original coil. This is a new coil. It means, sir, what is the change? So the change is, so the change is, sir, number of turns are increased. Number of turns. This coil with one turn, this coil with two turns. Sir, you have increased, you have doubled the number of turns, so the coil will turn faster. Motor or coil rotate faster. And using a strong magnetic field, yes. Sir, if you are increasing the strength of magnetic field, if you are increasing the strength of magnetic field, the coil will rotate faster. Okay. So question number 151, demagnetize a bar magnet here we have studied. Then this is the DC motor. What is the purpose of split ring commutator? We have discussed. Actually, if we increase the voltage of power supply, it will increase current. And if the current is increased, the coil rotates faster. Coil rotates faster. And now the next question. So the next question we should solve tomorrow. Oh no, sir, we can solve. No, no, no. We should solve tomorrow because we have two or three more questions on motor. And motor is very important topic. Motor is very important topic. So, but by the way, we have 5 minutes more, so I think we can solve this question. In this question, the first part of the question is, sir, why there is a turning effect when the current passes through the coil? When the current passes through the coil, why there is a turning effect? So the answer is, so the two sides of the coil experience a magnetic couple of magnetic force. Two sides of coil experience couple of magnetic force, and due to the couple of magnetic force the coil starts turning. And now, sir, you are given a table, and what do we have to do in table? I am explaining. The question is, what will be changed in the turning effect? What will be changed in the turning effect if we increase number of turns to 6? Sir, initially, but Atif, can you count how many number of turns in the given figure? How many number of turns in the given figure? Two. And now the number of turns are increased from 2 to 6. Initially 2, finally 6. It means number of turns increased 3 times. Number of turns increased 3 times. And if number of turns increase 3 times, it will increase turning effect 3 times. Initially 2 turns, finally 6 turns. Number of turns increased 3 times. If turns increase 3 times, turning effect will also increase 3 times. Okay, number one. And now the next part. So initially, the value of current was 3 ampere. And finally, the current is 9 ampere. 3 ampere to 9 ampere. Sir, again, current increased 3 times. And if current increase 3 times, it will increase turning effect 3 times. And now the last. The strength of magnetic field increase by 2 times. So strength increased by 2 times. So turning effect will also increase 2 times. So the turning effect will also increase 2 times. So as I taught you this formula, you can handle all these questions. So if we are increasing number of turns, if you are increasing current, if you are increasing magnetic field strength, then in the same ratio, turning effect will increase.